Hello everyone, I am Harish. I am studying 4th standard in Jawahar Vidyalaya. Today I am going to talk about quasars. Quasars are the brightest, most distant and most ancient objects in the universe. All the images were taken from the internet for educational purposes only. All copyrights belong to their respective owners. In this presentation, I am going to talk about quasars, discovery of quasar, formation of quasar, parts of quasar, active galactic nuclei, types of active galactic nuclei, microquasar, difference between quasar and microquasar, star-quasar brightness comparison, observation of quasar, Andromeda. What is a quasar? Quasar means quasi-stellar radio source. It has an extremely luminous active galactic nucleus. This is the active galactic nucleus. Quasars send out relativistic jets. The blue lines which come from the nucleus are the relativistic jets. Quasars are powered by supermassive black holes. A quasar glows with the brightness of 100 galaxies. Active galaxy is the host galaxy of AGN. Discovery of quasar. At first, scientists thought they were just stars. After they found they emit large amounts of radio waves, they named it as quasi-stellar radio source. In 1963, Dutch-American astronomer Martin Schmidt found the quest quasar. The brightest quasar, 3C273, is 2.5 billion light years away from Earth. 3C273 is located in the constellation Virgo. This is the quasar 3C273. Formation of quasars. Quasars are formed by supermassive black holes which have large accretion disks. Mainly, quasars are formed in young and colliding galaxies. Active galactic nuclei. They have extremely bright nuclei. AGN produce all the waves in the electromagnetic spectrum. This type of spectra is not produced by stars. AGN emits high energy X-rays and gamma rays. This is the electromagnetic spectrum. The distance between two crests or troughs is called wavelength. Long wavelength has low frequency and short wavelength has high frequency. Wavelengths are classified into two categories, non-ionizing radiation and ionizing radiation. Non-ionizing radiation are radio waves, microwaves, infrared waves. Ionizing radiation are ultraviolet rays, X-rays and gamma rays. The visible light is the light that can be seen by our naked eyes. Types of AGN: Seyfert galaxies, radio galaxies, quasars and blazars. The difference between all of these are their angle and their radiations. In this image, the green arrow is the observer's viewing angle. If the observer views from this angle, it is called as a radio-loud quasar. If the observer views from this angle, it is called as a blazar. If the observer views from any of these two angles, it is called as a radio galaxy. There are two types in radio galaxies, broad-line radio galaxies and narrow-line radio galaxies. If the observer views from any of these two angles, it is called as a Seyfert galaxy. There are two types in Seyfert galaxies, type 1 and type 2. If the observer views from this angle, it is called as a radio quiet quasar. Difference between This is the image of a blazar. When the relativistic jet comes towards the Earth or near the Earth, it is called as a blazar. In a quasar, it is tilted. In a radio galaxy, we can see both the relativistic jets. Seyfert galaxies are normally elliptical, spiral, or irregular galaxies which have a bright nuclei. Seyfert galaxies were found by Carl K. Seyfert. Difference between quasar and blazar. This is the relativistic jet in a blazar. It is surrounded by a accretion disk. In a quasar, it is tilted. This is the relativistic jet in a quasar. This is the accretion disk. And at the center, there is a supermassive black hole. Black hole. Quasars are powered by supermassive black holes. A black hole is a region in space of immense gravity. Even light cannot escape from a black hole. This bubble-like structure is called the black hole. The edge of it is called as the event horizon and the center is called as a singularity. The black hole is surrounded by a accretion disk which contains of matter, dust and gases. Parts of a quasar: magnetic field lines, relativistic jets, accretion disk and torus. This is the internal structure of a quasar. This is the host galaxy which contains the AGN. At the center, there is a black hole which is surrounded by a disk-like structure called the accretion disk. Relativistic jets come from the center of it. The accretion disk is surrounded by a dusty torus. At the end of each relativistic jet, there is a radio lobe. Radio lobes are formed when relativistic jets collide with intergalactic dust. Relativistic jets have twisted magnetic field lines. Microquasar. Microquasar is a smaller version of a quasar. It is powered by a stellar mass black hole. It takes a star's matter and forms an accretion disk. Microquasar does not need a galaxy. This is the star. Parts of a microquasar. This is the companion star. The black hole pulls the companion star's matter through an accretion stream. The accretion disk and accretion stream are joined together in a spot called as the hot spot. Relativistic jets come from the center of the accretion disk. Difference between quasar and microquasar. Quasar has a spinning supermassive black hole, but microquasar has a spinning stellar mass black hole. Quasar has a much larger accretion disk than a microquasar. Quasar emits UV and optical radiation, while microquasar emits X-ray radiation. The relativistic jet in a quasar is millions of light years, but in a microquasar, it is just about light years. Quasar needs a host galaxy, but microquasar just needs a companion star close to it. Radio lobes in a quasar are formed when relativistic jets collide with intergalactic dust. In a microquasar, radio lobes are formed when relativistic jets collide with interstellar dust. Intergalactic dust is the dust between galaxies. Interstellar dust is the dust between stars. Star quasar brightness comparison. In this image, the star is just 100 light years away, but the quasar is billions of light years away. This is the quasar and this is the star. In this image, you can see that the quasar is much brighter than the star. This image was taken by Hubble Space Telescope, also known as HST. Observation of quasars. Quasars are being redshifted. Redshifted means getting away from Earth. Blue shift means coming towards Earth. A quasar was found in 2007 by W.M. Keck Observatory located at Mauna Kea, Hawaii. This is the triple quasar. HST has been a key tool for these exclusive objects. As technology continues to enhance our windows to the universe, we may one day fully understand these fantastic lights. This is the image of blue shift and red shift. Blue shift means coming towards Earth and red shift means getting away from Earth. Andromeda. According to scientists, our galaxy, the Milky Way, may have hosted a quasar at its young age, but now it's not alive. In the future, after 4.5 billion years, our galaxy will collide with its major neighboring galaxy, the Andromeda. At that time, we may have a black hole. We may have a quasar. Thank you everyone. Thank you so much for Siva sir and CAC team for giving me this opportunity.
That was a nice talk, Harish. I hope to see you give more talks to the club in the future.
Thank you, sir.
So if there are any questions, please feel free to post in chat. We'll answer them. And until then, I'll probably show a few messages that we have already received. So yeah, we'll be having our next proper meetup in the coming Saturday. So we have two speakers from different observatories in Hawaii. One person actually works in the Keck Observatory that you mentioned. So the session will be about how to actually become a professional astronomer. So you should attend. And if there are any other interested people who are into this kind of thing, maybe you can inform them also. Okay. So are there any questions? We'll probably wait for a minute and see if somebody's posting any question.
Okay, sir. Thank you everyone for congratulating me.
We'll see for a few more seconds if somebody's asking any questions. If not, we'll probably end up the session. I don't think we are getting any questions. So thanks, Harish. Have a nice day. I'll see you next weekend.
Thank you, sir.